Good morning, everyone, and welcome to our 17th Fusion Friday. My name is Brian Multinsig.
My name is Alex Alvarez.
And we are application engineers here at KETIV Technologies. And we're here to make our partners more competitive and successful through essential guidance, technology, and support.
That's right.
Yep. And for those of you who don't know what Fusion Fridays is, it's a series of webinars that we do every other Friday. And we go over, it's pretty much training for Fusion 360. And what I'm excited about this Fusion Friday is that turning is part of CAM, right? And then CAM is the backbone of the CAM in Fusion 360 is HSM, and it's a very powerful tool that really helps a lot of people do their job.
Yeah, it's a tool that has some pretty good credibility, right? I mean, throughout the years, it's really helped people make a lot of money in their business, and has some decent credibility, right? So it's a pretty powerful tool when it comes to creating toolpaths, right?
Yeah.
All right, so like Ryan mentioned, today we are going to be talking about turning, right? So we've done a few videos or webinars on milling. We haven't really talked about turning that much, so that's why we decided to do cover that topic. So some learning objectives for today. We're going to go over the turning process overview. How exactly does turning work? Maybe some of you guys are familiar with it, some of you guys aren't. Right, so how do you set that up inside your CAM software? And then finally, we're going to program a part in Fusion 360 and post out to our machine, right? So like I mentioned, a lot of you guys may be familiar with milling, right? So your typical milling is over here on your left. You have some tool that rotates, not always, it rotates about the Z-axis, right? Sometimes it changes depending on if you're doing vertical milling or horizontal milling. So in this case, it is rotating about the Z, and then you have a stationary part, and the tool is the one that's going to be doing the rotating and cutting, right? Whereas in turning, the part is the one that's going to be rotating. You have some sort of a tool there going in and removing material and making chips, right? So that's a basic overview of really the two different types of machining. Again, that's just the general overview. There's a lot of configurations when it comes to machining. So these are really your most basic ones that you will see. All right, so in milling, you have your x-axis, right, going horizontal. You have your y-axis going in and away from you. And then the z-axis going straight up and down, right? So that's typically how you would set it up inside your CAM software, depending on how you have your part position in your vise, right? So how is that going to change for turning? Right, so here we see that we have our turning part. Notice now though that your axis completely changed, right? You have the z-axis going straight through the center of the part, x-axis going in and away from you. So if you look at the top right, when you look at the part, that's exactly how you're going to be seeing those axes, right? Also notice that the part is going to be rotating clockwise. So if you look at the part, you may be thinking to yourself, well, that's not rotating clockwise. That looks like it's going counterclockwise. But this is rotating based off of the machine's view, right? So Mark Terryberry, he's a Haas applications engineer. He does some pretty good videos on YouTube, and he has a pretty good analogy for describing the rotation, right? So just picture that this has some sort of, it's a face, right? So it has some eyes, maybe a mouth. So as the machine is looking out this way, right? So from the machine's perspective, the chuck is the one that's going to be rotating clockwise, right? So with that, let's go ahead and jump into Fusion and see how we would set that part up. All right, so here we have Fusion. Again, we are in the modeling environment of it, right? As soon as we are done modeling this part, all we really have to do is go into the CAM environment, right? We don't have to leave the software or really click on any add-ons. It's already built in, right, with the integrated CAD/CAM technology. So if you guys aren't familiar with the workflow, it's similar to milling. It's going to be a pretty straightforward workflow in the sense that we're going to be working from left to right. We're going to want to create our setup, add some toolpaths, right? In this case, now we're going to be working with turning. Then we're going to want to simulate those toolpaths, and then finally post out to your machine. Right, so here on the left, we also have our data panel. So that's essentially where all your projects are going to be stored. Again, if you wanted to invite someone to one of these projects, you always have the ability to invite them over, right? So let's see some of these right here, right? So some of the ones that I've created, let's say the A one, I can invite people over, right? Notice I have 4 invited, and I don't have to really send out any more emails or set up a Dropbox. They're gonna have complete access to that project that I have created and invited him over to. Right, as we work our way down, we also have our CAM samples folder, right? So here you'll find tons of information really on multiple types of milling, whether you want to see a basic 2D overview of the toolpaths, maybe you want to see some more turning information, right? Just click on one of these parts and you're going to have complete access to it. And also you're going to have the setup created for that part, right? So you can always dissect that setup and really take a look at some of the options or some of the toolpaths that the Autodesk employees are using.
Yeah, and since Fusion's connected to the cloud, they're always updating these folders, especially for CAM, because it's a very popular subject here in Fusion. And so, yeah, it's very powerful that Fusion's connected to the cloud for some of these reasons. You also don't have to worry about updating to the latest version of Fusion because you're always on the latest and greatest version of Fusion 360.
Absolutely, yeah. Yeah, so with that, you also have some work holding samples, right? So with this, let's say I wanted to really verify that I wasn't going to have some sort of a collision with the truck. I can just quickly go in here to the work holding, create a quick assembly with the truck in there, and then I can really verify that I'm not going to crash into it, right? Maybe you have a limited amount of stock that you're working with, so you really wanted to see how that would look. Just come in here, right? Open up the part and then just insert it into your current design. All right, so I'm gonna go ahead and exit out of here. All right, so let's go ahead and begin programming this part. Like I mentioned, it's going to be a left to right workflow, right? Creating our first setup. So if you guys didn't know machining all that well, you can just hover over some of the options inside of the CAM workspace, or really all the workspaces that Fusion 360 has, and it'll give you the tooltip, right? Giving you a quick description and a picture of what that command is going to be doing. So we want to create our setup. Let's go ahead and do that. Notice that we get a predefined rectangular stock. Our operation type, though, is going to be different. It's not going to be milling. It's going to be turning in this case. Right, so now it thinks that the z-axis is going this way. All we really have to do now is just select a cylindrical face, right, and we correctly position the part, right? So we're going to be starting off with a cylindrical stock, so we can just rotate this around a little bit and get the axis correct. Again, if you had some sort of a feature, maybe you're going to be working with a stock that already has some sort of a feature machine to it, right, some sort of a casted stock, you can always adjust your work coordinate here appropriately, right? But for our case, we're going to be starting from scratch, cylindrical stock, so we can just have this work coordinate as is. All right, so another thing that you'll notice in here, right, the model. That's the model that we're going to be creating toolpaths for. Usually when you create an assembly, you're going to see a couple bodies in here, right? So that's going to be essentially telling the software where do you want the toolpaths to focus. Now, if I had an assembly and I have multiple bodies in there, that's going to give you or result in the toolpath going into the assembly. So you want to make sure that in the model you just have the correct body selected, right? And for turning, we also have what we call this spun profile, right? So the spun profile, essentially, if you have some sort of disconnection in your model, right, it essentially creates those extents, closing the model so that it just gives you a revolved profile, right? So that's essentially what the software is going to be seeing, is some sort of a revolved profile. Again, you can hover over the option and it kind of gives you a description of what it's going to be doing there, right? So for our case, we have a couple features in the part that we can go ahead and turn on the spun profile. Right, so you also have in the setup the chuck reference, right? So the chuck reference is usually used for either if you're going to be doing some sort of secondary spindle movements in here, you're going to want to use that chuck reference. Sometimes when you're using the confinement option inside of the profiling, you also want to reference where your chuck is at, and then maybe stay, some sort of a distance away from that. So let me go ahead and just adjust the stock real quick before we do that. We're going to be working with, in our case, let's say relative size cylinder. I want a radial stock offset of, let's say, 1/8. Front side offset of 100 thousandths. And then the back side offset, let's say that we have an extra 1.5 inches. Right. So now what we can do then is go back to our setup. Right now we have our chuck reference. Now a couple chucks have some sort of a pocket or some sort of a seat inside the jaws, right? So what you can do is just measure that, and then let's say it was maybe 3/4, right? So what we can do is we'll know then that from the back of the stock to wherever the chuck is going to be at is going to be 3/4, right? So we can do from the stock back and say that it's, let's say, 3/4 away, right? So you can always adjust that. Maybe in this case we can pick less of the stock in the back, right? But for our case, that's going to be fine. Now, I do get a couple questions telling me, well, okay, well, I ran a profile toolpath, it passed the chuck reference, and I didn't get a warning, right? So you're not going to get a warning for the chuck reference. That's just so that you can essentially just use it as an option when you're creating confinements, right, or for your secondary spindle operations. I believe in the future, don't quote me on this, but they might do something similar to where if you do have the chuck somewhere close and it passes that plane, you are going to get an alarm for that toolpath, right? But that's, I believe that I saw that in the idea station, so that's something that you guys can actually refer, right, or let Autodesk know that you guys want to see. But for this case, everything looks good. Let's go ahead then and just proceed. All right, so just like the milling operations, the first step that we're going to be taking is a facing operation, right? So you want to make sure that you don't go over here to 2D face because you're not going to get a toolpath. Let's work under the turning operations, right? So turning, notice that you'll see that we have face here. Let's go ahead and select that. Right, so you'll see that we get the workflow here, so this little window. Now this workflow is going to look very similar, right? Because again, that workflow is exactly the same as to what you would do for your 2D or maybe even 3D toolpaths. Right, so we're going to start off with our tool, select the geometry. Now instead of the heights, you're going to have this radii tab working off of the center of the part. Right, very similar to heights though. Then we're going to have passes. And then finally, the linking tab, right? So again, just selecting our tool. Notice I created a tool library here already. We can use this CNMG tool. As we work our way here, again, similar to when we're working with the 2D toolpath, the 2D facing operation, we can just go ahead and select OK. Right? But remember that I left 100 thousandths on the front side. So let's go ahead and take that in 2 passes. So going under the passes tab, again, just saying that the max step over is going to be 100 thousandths, but I want a finishing step of, let's say, 20 thousandths, right? Or maybe even 30 thousandths. You can increase the feed rate here if you wanted to. I'm okay with this. All right, so now what we can do then is just create a roughing operation for this part. So again, under turning, profile, right, using that same tool, let's go ahead and just press OK, see what we get. Right, so we get the toolpath. Again, there's a couple things here that we're seeing that aren't okay, right? So first things first is that it's machining that face that we already machined on the previous operation, right? It's also kind of grooving into the part here. I just want the tool to come in here and just give us a straight toolpath just along the part, right? So what we can do, go to edit, and notice on the first one, the first tab here, we have this grooving option. Let's go ahead and remove that to don't allow grooving. And now under the geometry tab, we want to make sure that we do rest machining And again, this is where confinement comes into play, right? So right now we're just going to be machining up to this back of the model. Maybe I want to machine a little bit past that, so when I come and part the part off, right, I have a nice smooth surface to part it off. So I can do from the chuck front, right? So notice that our chuck is all the way over here, but I want to stay, let's say, a quarter away from the chuck, right? Maybe even a little bit more. Let's say 3/8. Right. So then from here, go ahead and select OK. Right, you're getting much better looking toolpath. All right. So then from here, what I can do then. So one thing I did forget to do though is leave some slack. So this is going to be a roughing operation. I don't want to do the entire part or the entire profile with this roughing operation. I want to use maybe a different tool. Right, so I can always go back into any of the toolpaths, even into our setup, and make those changes. Right, I don't have to start from scratch. Again, just right-clicking on the profile, edit. Again, similar to our 2D or our milling toolpaths, under the passes, we have the slack to leave option. Right, let's go ahead and leave, let's say, 20 thousandths radial and axial. Right, axial to the part. I don't want to leave any material. Okay, go ahead and do that. Right, so what I can do is I can come up here to the turning operation, select profile, or even better, I can have this profile toolpath selected, Control D to duplicate, and I automatically duplicated that toolpath, right? Same exact toolpath, same exact tool, same exact geometry selected. Now what I can do is just edit that toolpath, and then just select a different tool. The NMG in this case. Okay, so we do want rest machining. We don't want any roughing passes because we already took the roughing passes. And we don't want to leave any slot as well. Right, so once we press OK, notice that we get the finishing toolpath, right? So one thing that I just remembered of looking at this tool. I'm not sure if you guys are familiar, but Sandvik is doing some pretty neat stuff, right? They have some tools now that can machine from the back of the part forward, right? So if you do have that tool or those capabilities, you can actually do that or program that inside of Fusion 360, right? So if you go ahead to the profile, select edit, notice that we have the direction here. You can select back to front, and then that's going to allow the tool to come in from the back and then machine towards the front of the part, right? And again, you want to make sure that you adjust your lead-ins. I believe they have some set guidelines to adjusting the lead-in radius, right? But that's going to be for you guys to do some research on, right? But for me, front to back is okay. And then just click OK. All right, so now what we want to do is simulate, right? We want to make sure that the toolpaths that we've essentially been doing here are correct. So let's go ahead and highlight the entire setup and then just simulate the toolpaths. You can control the speed of the simulation here on the bottom. Right? You want to watch it go a little bit faster. Right? And there we have the part so far. Right, on the Simulate tab, you have a couple options. You can see the entire toolpath. You can show points, right? So you do have some sort of collision and you want to get some fine control of the toolpath. Notice that you have these points along the toolpath, right? You can select any point, and then that tool is automatically going to go or jump into that part of the toolpath, right? Little fun fact, all these points that you see are points that your program is going to essentially write out, right? So these are all going to be your X and Z points here on the toolpath. All right, a couple more things. You can make the stock transparent if you want to see the part actually inside your stock, right? You can stop it on collision, make sure that you know exactly where it's colliding. You can also see how long it's going to take to machine. Right? So far we have 6 minutes and 15 seconds, 3 operations, and 2 tool changes. All right. So now looking around this part, we can go ahead and do maybe some sort of a grooving operation, remove some of the material here. So let's go ahead and do that. Again, turning, groove by selecting our tool. This one right here. All right. So now we're not going to change anything on the first tab here. Now under geometry, we're going to want to confine that tool to where we want to machine. Right. So again, one important thing to remember too is that you can create templates from these tool paths, right? Especially turning. Turning has a lot of similarities in the sense that you're going to be doing a facing operation. Then you're going to come in here and do the profile, right? Some grooving operations as well. Maybe you have some drilling. There's a lot of repetition inside for when it comes to turning operations. So you can create a template and then just let the software work for you, right? You may have to come in here into some of the tool paths and then reselect some geometry. So that's what I want to touch on here. When you do create templates, you want to make sure or do your best to try and stay away from selections, right? So with selections, I mean, every model is going to be a little bit different, right? So that's why when you do create templates and you have a selection in there, that's when you have to go back in there and reselect the geometry that you want to combine, right? So for our case, we didn't know exactly the dimension here or the length from the face to its other face. So I'm going to go ahead and select it. But that's just one thing to keep in mind, right? You want to make sure that you try to limit the amount of selections that you make. All right, so now we've confined it. Now let's go radii, that's going to be fine. Let's go to the passes tab. Right, you have a couple options here as well. So if we look at the bottom, we see that we have a full step down, right? Again, hovering over that option, you kind of get a picture or an indication of what that tool is going to be doing. So some people prefer full step down. Other people prefer sideways with partial step down, right? It all depends on the rigidity of the tool that you're going to be machining this feature with. For our case, let's go ahead and do a sideways with partial step down. Right, from here you can control the grooving step down, let's say 50 thousandths. Right, and we can just go ahead and press OK. Right, so here we get a preview of the tool path. All right, so now let's go ahead and take care of this little counter boring here. So again, we can mix in some of these other tool paths in here, right? So for this case, we can do a drilling operation. Select the tool. Use 3/4 inch drill. Right. If I didn't know exactly what diameter size hole that was, I can just hover over the hole, and it tells me that it's a 3/4 inch hole. Right. All right. For this case, select the whole face. And let's pause here for a little bit and take a look at what's happening, right? So again, the yellow is indicating a rapid, and then the green is going to be a feed move, right? So we also get a preview of how deep the drill is going to be going, and we see that it stops at the bottom of that hole, right? So keep in mind too that we haven't machined any of this material, right? So what's going to happen as the drill is going to be rapiding into this section. You're gonna have a bad day. Maybe you're gonna be okay, but the machine's gonna make a loud noise, right? So let's go ahead and give it some sort of a clearance, right, under the heights tab. Right, so the drill does still stay the same. We still have the heights tab. The top height is going to be the model top in this case, right? And then the bottom height, let's make that the bottom of the model. We can clear it by, let's say, 1/4 inch, right? And it extends that bottom of the drill bit 1/4 inch. All right, so from here, everything looks good. We can, again, go to the last tab, the cycles tab. You do have the option to do chip breaking, right? If you were going to be using a reamer after this, maybe get the precise hole, you can use the reaming option. And for our case, we're okay with drilling. Go ahead and hit OK. All right. Let's go ahead and simulate what we have so far to make sure that we're on the right path. Let's turn off transparency. Okay, so there it goes. All right, so that after this drilling operation, notice that we are going to have some sort of a clearance to bring in our counterbore tool. All right, so let's go ahead and take care of that. We go to turning, profile, and notice that we get the tool here, right? So how are we going to get that tool inside this face here, right? So first thing that we would have to do is do an inside profiling, right? So that kind of positions the tool a little bit closer to the face, but there's still no way that we're going to get that tool inside there, right? So let's go ahead and select an appropriate tool for that. Again, I already have a tool here created. If you guys weren't aware, there is a samples tool library for turning, right? So under samples, turning at the very bottom, notice that we do have a couple tools already created, right? So lathe tools are a little bit harder to really model sometimes or really get right. So I definitely suggest you guys to copy some of these tools and then bring them into your tool library and then adjust the parameters appropriately, right? So for us, that's what I did here, right, on this grooming tool. We can go inside the tool, edit the tool, right? We have all these capabilities. You can edit the insert that you're going to be cutting with. So for the holder, right, notice the setup is a little bit different, right? So for the setup, instead of 0 degrees, it's now going to be 90 degrees, right? So that it allows me to machine that hole appropriately there. I also brought down the size of the holder, and everything else is going to stay the same. So let's go ahead and hit OK. Select that tool. Right, so now we get an appropriate tool for that. Right, so now we haven't really talked much about the radii, so let's go into the radii. So typically, I recommend you guys working from the top down. In this case, though, I'm going to have to tell you guys to work from the bottom up, right? So I personally, I mean, that's going to be a personal preference, but I feel like it makes things a little bit easier to understand. So let's talk about the clearance. So clearance is essentially the area that your tool is allowed to go into, right? So we created a 3/4 inch hole. Now we can do a clearance of 0.75, but that's cutting it a little bit too close, right? So let's go ahead and specify a diameter, and let's just say 0.7, right? Clearance of 0.7. Okay, so now the inner radius, where are we going to be starting our cut from, right? So let's go ahead and select that to that pocket or that hole, right? And then outer radius, where's our the max outer radius that our tool is going to machine to? This outside face right here, right? You can go to the passes tab and edit the step downs or the step overs. In this case, I'm okay with that. And we get the tool path there, right? Now, sometimes you have some extra material, maybe the shape of the tool, and you don't want the tool to retract back down once it's done machining. What you can do then is edit the tool path, right? So then from go home, notice that we have right now set to go home at beginning and end. All we have to do really is just change that to go home at beginning. Click OK, right? So as soon as it's done machining that, it's just going to come back up. And it's not going to go back down to the center of the part there. Okay, so from here, really all that's left is to part off the part, right? So let's go over here again to turning part, and once again selecting the tool. All right, let's go ahead and use this tool number 1, our part off tool. And notice that we automatically get a tool path, right? So it automatically knows where the end of the part's at, and it cuts off appropriately. Now you can always adjust that, right? If you always wanted some sort of an offset, maybe you wanted to come in here with the, just sand off or something, you can always increase that offset. But for us, let's go ahead and select OK. And once again, just simulate entirely the entire tool path there. So using that one. There's our counterboard tool. And there's our part off tool, right? So there we go. Again, if we had the mill turn capabilities, maybe we want to take care of these features inside the mill turn. But now essentially the part's ready to go get transferred to some sort of a mill, right? And then just machine some of these features on the outside of it. But for us, our job is done in terms of the turning. So let's go ahead and post it out. Now again, there's hundreds of posts already included for Fusion 360. Right? So bring out this drop down. Notice that you have your Fanuc turning. You also have your most common one, right? Haas turning. You have a couple options here to really select. For us, let's go ahead and do Haas turning. Again, if you ever wanted to modify the post, which I don't recommend if you guys aren't too familiar with coding. But if you are, you can always modify the post and then you know, do those small modifications. Now, I don't recommend you guys modify straight from the open config. Really, the thought process behind that is if you do make a change, it's going to change your internal post, right? So what you want to do is go to the Autodesk HSM post library, download the post for your machine, and then do those edits there, right? So that way you have this original one saved as is. You can actually do that, by the way, right? So let's say that we did have a mill turn lathe. If you scroll here on the bottom, notice that we don't have any of those Haas ST models. Right, so what you want to do then is go to the Autodesk post library, enable this filter in mill turn, right? So now we have the Haas ST30Y, Doosan mill turn. Right, so we have a couple options here for the mill turn lathes. And all you really have to do is just download it and bring it into your cloud post. If you guys do have questions on that, feel free to reach out and I can either send you a video or maybe we can jump on a call and get you guys taken care of. But for our case, we just have a simple 2-axis lathe. So let's go ahead and use the Haas turning. Give it a program number. You already have some user properties here built in that you can change. Kind of post it out.
I believe initially when I posted my G code, we didn't have brackets installed, but you might, for the new users, you might need to install brackets to read your G code.
Yeah. So if it is going to be your first time posting, it is going to ask you to download brackets. So brackets essentially is our NC viewer, right? So it's what the tool that lets you really see the program, the G code program, and you can also make edits. Right, so M31, a lot of people don't have the chip conveyor. Let's say you have a Haas TL1, you can just delete that code out, right? And you're not going to get that alarm anymore. All right, so from here, let's go back. All right, so let's say that your customer decided to change, right? That's not common, but it does tend to happen, especially in small machine shops where customers aren't happy with the current model. Maybe they just got a new part overall and it's somewhat similar to this, just with some smaller changes, right? So what we can do is go back into the model, right, profile sketch, edit that sketch, and rotate it this way. So in this case, let's say they brought that down to 1/2 inch, right? So the part shrunk overall. Let's see here, what else? Let's say this groove decreased to 0.2. Right, so now if we stop the sketch, right, so made a few changes there, go back to cam, we get these red exclamation points telling you, well, okay, you went into the modeling workspace, you made some sort of a change to the model, go ahead and regenerate that toolpath to get the most up-to-date toolpaths that you have, right? So notice right away, we don't have to start from scratch creating our new setup. We already automatically get those toolpaths.
Right. What Alex just showed was super powerful because he not only hopped back to the model workspace and then click of a button and change the design, but he was able to hop back quickly to the CAM workspace. Didn't have to create all those new toolpaths from scratch like some softwares do, and he just hit 2 buttons at the same time, and then it recreated the toolpaths for this entire part.
Yeah, definitely super powerful, like you mentioned, and that's saving people a lot of time, right? I know some CAM softwares require you to
It looks like we have one question from John here. He's asking if you can simulate your own custom tools in the simulation. I think it can.
Yeah, so form mill tool, that would be our form mill option inside of Fusion 360. So you can create your own tools. Once you create that own tool, you can just use it as any other regular tool, right? So I believe we actually have a webinar on that as well. So be on the lookout for that one.
All right, looks like that's it for the questions. Thank you guys for watching. Once again, we are KETIV Technologies from Autodesk Platinum Partner, and we'd love to help be your partner in manufacturing innovation together.